Me again, hello. Nice to see you back. Still looking fresh. Today I want to talk about the other data. Not the one that everyone usually has, you know, very well georeferenced, getting it from some source. I want to talk about the things that you collect instantly or that you want to hook up and link and give it a geolocation. And the first question is actually, why does my machine not do what I want it to do? That's the first question. Yeah, here we go. Why do you want to do this? So let's try to get back. Now it's awake. Well, I think a pretty common scenario is this one. You just need ad hoc documentation. Digging up a road as a service company or crashing your car into a wall might be reasons for doing that. All of you have mobile phones. If they are sort of reasoned and you turn it on, they will capture the geography where you're at, and which is sort of the one and only additional requirement, they will sort of capture the direction you were just looking at in degree usually. So it knows the orientation of your image. Then you can do things like this and get ad hoc documentation that is then linked to your data, which we will see in a minute. The other thing is more detail. You hear all these talks about those nice generated meshes and true orthos from drone and reality capture. But to be honest, everything you produce is always a little less good than all the original images that have been captured. And it is a quite interesting concept to say, I have actually both. I have the original images and I have the processed 2D and 3D results of that processing. Then there is actually sensors that they are not really mappable. The typical 3D dome capture is one very good example of that. And to get this into your system and to be able to see where am I actually looking at, where roughly is this object in real space, is a third very common option why you want to use something like this. And then we have these drone and aerial imagery created data that nowadays often has not only the nadir aspect, but it also has the oblique aspect. And we can take this data and give it a second meaning by integrating it with this kind of technology. So again, similar to the whole imagery story, we want you to be able to use basically data from any kind of device, which is street level, or it could be something else than street level. It could be, as I said, what the drone does, or what you do, or what a plane does, and you are able to integrate that in a different way. What you can do then is sort of highlighted here. You can geo-relate the data. You can get different views of things. You can start depicting, okay, this point on the image is sort of where in real space, and the other way around. You can, I'll talk about that in a minute, do measurements. And in the near future, you will be able to run deep learning algorithms against these images right away and then put the results on the map right away. These are all things that are going to happen very, very soon in this area. From an ArcGIS perspective, we always try to give you the same order of capabilities. So job one is always to manage this data, to have it somewhere and then integrate it, publish it, share it, so that users can then use it and you put it into applications and give access to whomever you want to give access to. But the real nice thing about this is once you've done that, once you've published it, you can use it in many, many places. And these are the mobile apps, these are the viewers, the standard web viewers, the web app builder and experience builder app, quick capture, ArcGIS indoors. I have no idea what you in the room are actually using out of this series, but you basically see now it's part of the standard data model, and once you've done the basic work, you can bring it to all your active environments that you're working in. And there will be more to come. The intriguing thing about this oriented imagery, as we call it, is actually the simplicity of the data model. You might know that when you go into photogrammetry, you have a quite complex data model of how things relate to the ground. It's polygon based, it has a lot of metadata needed. Here the data model is simplified to basically a point feature class with a few attributes. And that can help you to take virtually millions and millions of those records without massive load to your system and use them in a nice way. As always, there is a series of attributes that needs to be filled to make this working. And this is actually really the topic with oriented imagery. Where do those come from? As I told you, in this very simple case, there is a way, but it's definitely not the most precise kind of data you get. You can imagine that when you drive one of those ground-based capture vehicles with high precision gyro instruments in it, you have another quality level of data, and that will reflect in the capabilities you have in oriented imagery. So in the background, things that are known from photogrammetry will also happen here. Hopefully you will not have to need to know. But please, if you have some kind of data like this and you do not know how to get it into the system, contact AlphaGIS. We know how to do it. If the metadata is there, we can help you to get it going and done. It's very, very customizable and we'll help you to do it. The whole data model, we don't have time in 20 minutes to go into that, is very, very much targeted to having huge amounts of those data sets and then simplifying properties like you take all the data, you push it to another storage location. It's basically one line you have to change and then it will work again. Things like that have been considered so you can work with it nicely. There are properties, generic properties, feature item properties as you know it from other things. This is just part of the data model and I don't want to dig into it. I just want to repeat that this allows you to load virtually any kind of data that has sort of this metadata into the system. Create you a system table like you know it from other data sets. It's just a point feature class with attributes that you can use. Now, I want to switch and look at a few things here. Since the integration into the core product, it's really workflow-wise, it's really what you know from other things. Now when you go to a file geodatabase or any other geodatabase, you right-click, see you have the ability to create an oriented imagery dataset, which will create the table schema with the necessary fields. All this is as standardized as many, many other things. The first example that I want to show you in here is actually from the place I live at. And I just took my mobile phone and I took a few photos, and after I did create this data set and say load data, I have my first oriented imagery data set. You can see here it's a point feature class basically. So let's move away from that point feature class and remind you of the context sensitive ArcGIS Pro user interface. So if I go to that point feature class, it recognizes it's not only a point feature class, it's also an oriented imagery layer. And with the oriented imagery layer, I have the capability to now explore this oriented imagery layer, explore the data that's in there, and query my my data. Now, this is really how it looks, very close to my home, most days of the week. Now you see this red triangle there, which gives you an idea, where did I look at when I took the photo? The photo tells me what did I see when I looked at it. And you also see that there is a connection between the two. So if I want you to be a little closer to that cow, see that red triangle moves and tries to give you an idea where I'm currently looking at. This can be really, really helpful. And now I have to repeat that. This is the most simple sensor that you can import here with least quality in terms of detail. A mobile phone doesn't capture anything like whether you hold your phone like this or like this or like this, right? It doesn't know any tilting, which is really important in terms of where you're looking at and what you're seeing. Higher quality sensors will give you completely different quality in that regard, which I'll show you in other examples. The other conceptual thing you have to understand is, I'll turn off the base map for a second. You see all the green areas. The idea of oriented imagery is not that you click on one of the points, which is the location where the camera was when it took the photo. The idea of oriented imagery is green tells you there is something to see here. You click anywhere in the green and it will try to select the most appropriate image. Let's go to another place in my hometown. The most appropriate image that meets the point that I was looking to. I might have several images that overlap in this area. Then the system allows me to choose more images. Let's go to a place where there are potentially more images. No, only one. Hit more. Yeah. Here is a second one. So I can choose a second image that basically shows me the same location, but maybe from a different angle. And then I start using this interaction between the map and the data. That was a very short glimpse of this, how it looks in Pro. But as always, the whole idea is that you can be using that in your enterprise environment with online clients. I would recommend that you spend a few minutes at some day you have time in the office to go to this place. If you search for oriented imagery examples, you will get a long list. And I'm going to show you a few. This would be the same thing that you just saw, so we're not going to do that. This is an example from a Portuguese road company that has a mobile vehicle that captures data. These are only for you to simply see the 360s. And you see that it's a huge density of those 360s on a very short range of data. We have different viewing locations that we can use here. I want to use the 360, and now I'm querying the system once, and on 360, it's clear. I'm going to 3D now. We see the location I'm looking at now as a 3D viewing thing, right? And it's the same thing again. If I now start looking more to the ground, the whole thing moves more to the ground. If I start looking around, it'll look around. It also tries to use the terrain to see where there is some shading that might prevent me from seeing other things. So it's always the same thing. Once you have the location information, it tries to give you this idea. And it tries also to allow you, not in this one, I'll do that in another one, to depict places on the map and see where they are roughly in that thing. For those of you who are deeper in the topic, if you have depth maps of images and stuff like that, you can do measurements in there, but that requires higher quality data. So the same thing in 2D, but now with the other cameras that this vehicle drives, might look like this. So if I look at one of the back cameras that it has, just left backward. Very nice. Oh no, and sorry, these are the ones here. So this vehicle, for example, has cameras that really just, they go to the tarmac, right? The only thing this thing is about to do is see things like this, cracks in the road, and it's high detail. It's thousands and thousands and thousands of images along very short stretches of motorway, and this is a way to integrate them into your system. We talked about that yesterday. You might capture LiDAR at the same time. This is from a Regal mobile mapping system, and the map just depicts both things. So if I go to this US location here, where there is a driveway here where the vehicle was on, we now have the combination of the both things we saw before. The LiDAR data basically illustrating what you see, and then you have a 360 here again, so you start moving around and seeing the area and where you're actually at. Another LiDAR example, this time more from the utility space, also shows you what the difference between the LiDAR capture and the image quality you potentially have is, and why both are quite interesting here, giving you the full 3D impression, and here a high quality 2D depiction of the same thing. And finally, the one that I talked about when you look at aerial imagery or drone data that you process to a higher level. This is my birthplace, Munich, and a very nice actually 3D model of Munich created from high resolution aerial imagery. If I go down here now, this place used to be very well known to meet amongst young people. But you see, we're not into modern art in central Munich in terms of historic things. This is the limit that you get sometimes when you do these processings in 3D. Now, if I really want to get a better idea of how this actually looks like, I pick some of the original photos that were used to capture the whole thing. Going here, let's catch up. And now we get the impression that's what the photo is, right? The photo is not better than that. How this really looks. By the way, do you recognize why in here some of the people are not visible, or some people are not visible? Some are. Why they are gone? That's part of the processing with something like reality, where multiple images will be combined, and if something is just on one image, it will be gone. So moving cars, moving people, things like that will be gone in the final process of the true ortho or the 3D model that you're using. Briefly back to that demonstration. I don't want to go into too many details here. We will look into this in the workshop tomorrow a little bit, but there is a huge way of customization built into the product. You can have, as I said, your own metadata schema, and it's well described how the table needs to look, which routines you can call from ArcGIS to transfer information into that data model. You create your custom input type, you're ready. We've done that probably 10 times in the last 6 weeks for different vendors and their formats and how they provide data. And we were successful in every single case, and we will be in yours too. So please look into oriented imagery. Start by going out with your phone, do a little test, learn about it, and make this data available to the people in your organization. You all know humans are visual people, right? If you have a real person's look at something, you understand much better than looking just down or getting a written information. Thanks a lot. Any instant questions?